All right, guys, so this afternoon, we're going to take a look at, just getting a little bit more and more complicated, right? We're going to look at the derivatives of composite functions. And if you guys remember what composite functions are, it's where we have like functions inside of functions, right? And so what we're going to see is what we're going to learn today about the chain rule, okay? Recall that one way of combining functions is through the process of called composition, and the definition of a composite function is as follows. If we're given two functions f and g, the composite function f dot g is defined by f dot g of x, which is this. We have function f, and inside of function f, we put the entire function. This is some grade 11 functions material here, right? So it doesn't matter. It doesn't matter if you're evaluating something at f of 2 or f of x plus 2. Whatever you see here is what's going to go in place of the x. Okay, so I just want to do a couple examples here, just to re-illustrate this idea. Okay, so if I have one function, f of x is root x, and g of x is x plus 5, we want to find the value of f of x, right? Remember, this is just f of x, and wherever I see this, I'm just going to replace the x value with whatever it's telling me to replace it with, right? So f of x, the function f of x, is the square root function. Oops. Right? And so f of g of x is going to equal the square root of, well, I'm going to replace the x with the function g of x. So I'm going to say x plus 5. Okay? And for this function, we're just going to do the opposite. This time I'm going to take function g of x, and everywhere I see the x, I'm going to put the root x, root 2 root x. Okay? So I'm going to say, well, g of f of x has to equal root x plus 5. Okay, so this is what we call a composite function, okay, where one function has another function inside of it, and so you better expect that we're going to need a way to derive this. Okay, so and that's what I'm getting at here, I suppose, is how do we derive a composite function like this? Okay, well, we have this, our friend, chain rule, okay, and if f or g are functions that have derivatives, then the composite function h of x is equal to f of g of x has a derivative given by, okay? So if I were to derive this h of x function, h prime of x, it's going to equal to the derivative of f as a whole, so the big piece, we're going to take the derivative, almost like power law, right? And then I have to multiply by the derivative of the inside, okay? That hopefully, not hopefully doesn't make sense, but I understand if it doesn't. This is a little bit complicated, okay? It makes 100% sense once you see a couple examples, okay? And that's what we're going to do right now, okay? So what I want to do is I want to run through like 4 examples here, show you guys how to use chain rule and find the derivative, okay? And then the same rules apply if I wanted the slope at this given tangent, if I wanted the equation of the normal, things like that. Just solving for different slopes of tangents for a particular function. Okay, so for here we got f of x, right? And it's given by this function. What we could do is say, okay, well, I want to find f prime of x. F prime of x is going to equal, what do? I take the derivative of the entire piece, right? So I'm just going to apply power rule here. So I bring the 5 down, so it's going to become 5 times 2x squared minus 3x to the power of 4, okay? So there's the first piece done. That's this f, take the derivative of f with g of x still inside. But then it's telling me, chain rule tells me to multiply by the derivative of g of x. Well, this is g of x here, the function inside the brackets. So then I have to multiply by the derivative of the inside. So I'm going to multiply by 4x minus 3. Right? And if you were to collect this, you should get, it would be 5 times 4x and 5 times negative 3. we would have 20x minus 3 minus 15, and that would be multiplied against 2x squared minus 3x to the power of 4. Okay, that is chain rule. It's in two parts. This part here, where we take the exponent, move it down, and then we derive the inside. Okay, that's chain rule. So we could do a couple more. So, and they get quite well, you can get as complicated as you'd like, but you know, just follow the same rules, right? It's just 2 times negative 4x to the power 5 minus root x, right? No problem there. The exponent there is 1. And then you still have to multiply by the derivative of the inside. So I suppose, let me do one thing before we do that, okay? Let's just what I'm going to do here is clean up the square root. I don't want the square root there because that's harder to derive. Okay, so you could say, okay, well, f of x is equal to negative minus x to the 1/2 squared. Okay, that's better. Now I can derive that easily. Right, so the 2 comes down like what we did before. And then multiply by the derivative of the inside. Okay, and I'll move all this over so we have some room. Not colliding with the other question. Okay, you could further simplify this, I suppose. You could expand in, but that just makes the numbers bigger. It's sometimes nice to see the factor out front as well, right? So you don't necessarily want to multiply that in. We could rewrite this thing over here, though. And I suppose you could put this back. If you really wanted to, you could put this back to root x and multiply that by negative 20x to the 4 minus 1 over 2 root x. I don't know if that makes it easier or not. It's just cleaner, I suppose. Okay, so there's your derivative. Then if you wanted to, you could find the slope of the tangent at x equals 1 if you wanted to, right? You could find the actual slope. Don't forget about that. And subsequently the equation of the tangent, things like that, okay? You could do all that work with this as well. So let's find the derivative f prime of x here. Well, let's rewrite f of x because I don't like square roots, right? It's nice to be able to see what the exponent is, so I just rewrite it, 3x squared plus 1 to the 1/2. And that makes f prime of x would be 1/2 times the original 3x squared plus 1. Now remember, when you apply power law, I should have mentioned this before, you always have to subtract 1. Don't forget that, right? That's where some of these exponents are coming from. Okay, so we're going to get a negative 1/2 here, because 1/2 minus 1 would be negative 1/2, and we have to multiply by the derivative of the inside, 6x. So we can clean this up. You guys know with a negative exponent, that could be moved to the denominator. And so f prime of x is going to equal 1 over 2 times 3x squared plus 1. We could make that a square root now. I'll leave it as a 1/2 for a sec because we have one more line to do. And multiply that by 6x. Well, over 1. Well, 2 can cancel out with the 6. Or at least 6 divided by 2 is going to be 3. And so f prime of x is going to equal 3 over the square root of 3x squared plus. Okay, make sure that's right. All right, we're good. Am I missing something? Oh, I am missing something. Sorry, there's an x on here as well. Don't forget the x. There you go. Now we're good. Good thing I checked. Okay, and again, the 2 divided by 6 is what got me the 3. Okay, that's it. One more. Now, you might be fooled at looking at this and thinking, oh, this is quotient rule. And I suppose you could apply quotient rule to this. But you could also apply chain rule. Okay, and I think chain rule might be easier. Okay, so what could you do? Well, this doesn't look like chain rule. Well, you could take the denominator and bring it up. And when you do that, you're going to rewrite the function like this. It's 2 multiplied against x squared minus 16 to the power of negative 2. Right? And so let's just apply our chain rule. Well, we can bring the negative 2 down. Right? So we're going to have f of x, f prime of x now. And I'm going to leave the 2 alone here for a second. I just want to tackle the derivative of this piece explicitly. Okay, so we'll have negative 2 x squared minus 16 to the negative 3 multiplied against the derivative of the inside, 2x. Okay, so it looks like f prime of x is going to equal 2 times negative 2 times 2. Right, well that's negative 8 over x squared minus 16 cubed. Okay, so we'll hit pause there. Okay, and then I'll explain this bottom. It's just a different notation. Okay.